Water scarcity is what limits the agricultural productivity in drylands, driving farmers to overexploit the meager dryland water resource, bringing about water resource depletion that results in desertification. At the Jacob Blaustein Institutes for Desert Research at Ben-Gurion University of the Negev, Dr. Amit Gross and other scientists are looking for alternatives for the desert's scarce water resources in an effort to ameliorate living conditions of dryland farmers. Gross's motto for this project is, "One man's waste is another man's treasure." He and his team are focusing on the development of small-scale water recycling systems, which would be particularly suitable for remote desert ecosystems. One project that they developed is a way to recycle domestic graywater, a comprehensive term for all liquid wastes except sewage. By treating the water with a small, aesthetic, inexpensive bioreactor, the researchers have been able to reduce household water use by 30% or more. The device that they developed uses bacteria as a catalyst to break down detergents and organic materials as part of a filtering process. The water can then be reused for irrigating dryland crops with no risks to human health. A common problem throughout the Negev is the abundance of goat manure, which poses a serious environmental hazard. It smells bad, attracts vast swarms of disease-bearing mosquitoes, and often contaminates subterranean aquifers vital to continued human habitation. Dr. Gross and his team have found a solution for this as well. Using a small, efficient chemical reactor, the researchers have been able to extract a methane-rich biogas from the droppings. This gas can then be used by local Bedouin shepherds as an inexpensive, readily available source of green energy for cooking and heating. It also reduces the greenhouse effect caused by methane gas emissions from untreated dung. But Gross and his colleagues have not stopped there. They are also converting poultry droppings into liquid fertilizer and solving the problem caused by another methane-rich waste product, which carries disease and a foul smell.
So we introduced the manure into the reactor and trying to extract nitrogen, which is an essential nutrient to plants, by microbial means. The microbes digest the manure, and the nitrogen is then volatilized into a second reactor where it is being converted to liquid fertilizer that is used in the organic agriculture. The waste coming from these reactors is then utilized as compost and for other agricultural purposes.
The practical implementation of this research has succeeded in transforming hazardous wastes into valuable new sources of renewable energy that can reduce the dependency of dryland people on fossil fuel and mitigate global warming.